Hello again, everyone. My name is Melissa Raspberry, and I have the distinct pleasure of working for the American Institutes for Research. It's based in Washington, D.C., but I get to work remotely from home in Durham, North Carolina. We are the organization that manages and oversees the CS10K community, and we're so glad that you all joined us for tonight's webinar. We've been conducting these webinars at least once per month, actually multiple ones since the start of the school year. So if this is your first time joining us, we hope that you'll stay connected with us and be a part of things in the months to come. Just a few quick notes before we get started. Deepa Muralidhar is our facilitator and host for the night, so she'll take things over and kind of navigate the conversation. However, I'll be here and be checking on things in the chat window and can assist if there's any technical issues that you run across. One thing to note is that we do encourage you to call in to the phone line or join via audio, because we like to have these as interactive as possible, and that you're welcome to not only ask questions in the chat window, but also orally by phone. If you're not speaking, we do ask that you please mute your line. I'm hearing a little bit of background noise right now. If you're connected, it can be very sensitive with sound. So if you are connected by phone, just mute yourself. In the top, you can either do it on your phone itself, or on the top toolbar, there's the black toolbar at the top. I have a phone icon and a drop-down menu, and one of my options is to mute my phone. And so you'll want to do that if you're not speaking correctly. But we'll go ahead and I'll turn things over to Deepa, and I'll be in the chat window if I can help you with anything else. Thanks again for joining us tonight.
Hello, everybody. My name is Deepa Muralidhar, and no stranger to the teacher community in computer science education. Good to see you all this evening. Today, our topic is CS Principles Big Idea 7, Impact. And as we all know, one of the big things about CS Principles is to encourage creativity, collaboration, and exploration, giving open-ended projects to students. And Impact definitely lets us do that by helping students try and really explore around computing innovation. So today here we have 3 guests who have joined us to talk about the Big Idea Impact and how we want to maybe encourage our students to use it in the classroom. I have, as always, we first do the introductions, let our guests talk for a few minutes, and then we'll pose some questions to them. As Melissa said, I want to reiterate, this is meant to be an interactive webinar. We ask you to pose your questions, not be shy. We will keep asking you for them, and please go ahead and ask and participate. Okay, so here I am excited to introduce Paul Tymann, who is currently serving as a program director at NSF. He also is a professor at Rochester Institute of Technology. I am honored to also say that he is the chief reader. College Board had invited him to be the chief reader for the first APCS Principles exam that will be conducted in May of 2017 and graded that summer. I'm honestly honored also to mention that Paul Tymann has worked as a co-chair for the APCS A Development Committee, and to me that really speaks volumes, because he is very closely knit with our community as understanding what the teacher community needs are and how exactly, or what are the challenges that a computer science student runs into at the K-12 classroom. So we welcome you here. I would next like to introduce Tiffany Barnes. Tiffany and I go a long way back. I don't even know. I guess it was with the College Board pilot. Tiffany is a very accomplished professor. When I was trying to look up stuff on her, I was just amazed at the amount of awards she'd won. And I want to assure you that the number of bullets I've put out are very, very difficult to pick out from, and were very, the best I could think of in a very, very large superset of accomplishments. Tiffany does 2 important contributions. I'm sure she'll share it with us. But in my mind, she has taught this in the classroom, like the way when I spoke to her. She has rolled up her sleeves and actually taught C principles to the higher ed students, and she's going to share her insight and wisdom. And finally, Baker Franke. Baker, when you speak, you've got to tell us how long I know you. We've known each other since the Computer Science Teachers Association started, I believe. And both of us were excited to be part of the CS Principals pilot when College Board announced it. And we've done several presentations for CST and College Board together. It was with great excitement when I heard that Baker had accepted to work as a curriculum in chief, as I call him, but I believe he's the education program manager at code.org. And we have lost my screen. All right, thank you. And he will definitely share his wisdom with us on these areas. Okay, at this point I'd like to pause, and I'd like to have our guest talk to us. Paul, the floor is yours, sir. If you'd like to tell us a few things about yourself.
Well, I don't know, Deepa. You covered just about everything. I'm happy to be here and looking forward to the conversation.
Okay. A little more about yourself, your involvement, maybe?
Well, I mean, you pretty much wrapped it up. I'm involved with the AP computing exams for quite a while. I was on the AP CSA Development Committee for, I think, a total of something like 8 years, and I've been working on as the CS Principals Chief here for a couple of years now. I put together a CSP type course at RIT, and we were teaching it before I came to work down here at the NSF.
Well, welcome. Excited to have you here. Tiffany?
Good evening, everybody. I'm Tiffany Barnes. I'm from North Carolina State University. I first taught the Computer Science Principles course for the College Board pilot in 2011 at the University of North Carolina at Charlotte. Since then, I moved to North Carolina State University, and I've been working with professors at UC Berkeley, Dan Garcia and Brian Harvey, who made their excellent Beauty and Joy of Computing version of CS Principles. And we've been working together to provide professional development opportunities for teachers. I had over 200 teachers work with us in different workshops, some of them shorter, some of them longer, and we're very excited about that. And now BJC is being implemented in New York City, and we're also continuing to build partnerships with universities to support high school teachers teaching the new course. So if you are interested in working with a local university to try to help support your efforts and your CSTA, be sure to email me after the call, and my email is just tiffany.barnes@gmail.com.
Cool, welcome. Baker.
Hello, can you hear me?
Yes, perfectly.
Okay. Hi, everyone. My name is Baker Franke. I am a former high school teacher. As Deepa mentioned, we go way back. I taught high school computer science for 13 years before joining up with code.org. I was in a group of small, sort of 10 high schools that piloted CS Principles a few years ago. Was that 2013, 2012 maybe? I can't even remember. Now at code.org, what I spend most of my time doing is working on building out our CS Principles curriculum. We're kind of new to the block, and our course right now is being piloted by about around 100 teachers, sort of officially, about 200 or 250 unofficially in various places around the country. And I think through the conversation tonight, I can tell you more about it. We also do have a professional development program, though I don't run it, but I can answer questions about it if you have them. I think that's it.
Great. Welcome, everybody. So let's start. So one of the things that as I teach CS principals in my classroom. I think in my syllabus, I remember when I was holding a PB with somebody, they said, your syllabus, Deepa, has so much of impact on it. Why? And I was trying to explain to them, and I said, that would be such a good webinar as to what are the key factors that are important to discuss with our students so that they really understand the impact of computer science and so that they really understand the pedagogy, pedagogically, what we are trying to teach them with CS principles. Tiffany, would you be able to share this insight with us, ma'am, with your experience both with us holding these PDs? How do you teachers teach them? How do you teach these students? Keeping in mind that we do have a flavor of CSP, which is E, how would you recommend that teachers go about getting students ready for college to understand this important concept?
When I'm thinking about impact, I also think about the big idea, how you've written it, is that we want to talk about the influence of computing innovations on society. So I think it's important for us to make sure we know all the definitions. It has to be about, if we're talking about computing, they need to be innovations, they need to be about society. But it's hard for a high school student or teacher possibly to think about, what might be an impact of a computer. And partly because for high school students, everything that they see around them doesn't seem like an innovation. It seems like the way everything is and should be, probably always. So to talk about what might be different in your life if you didn't have devices and computers, what would you have to do differently, or what would have to be done differently? For example, if we didn't have the internet, what would we have to do? We'd have to go to the library to find information because that's where information used to be aggregated. If we didn't have a search engine, we would have to look at a lot of pages before we could find the thing we were looking for. If I didn't have access to the internet on my phone, I'd have to do very different things than I do today. I'd have to have a computer with an connection. I try to connect it to the things that kids and parents and schools do every day, because those are the things that the high school students are seeing. Another example might be, it used to be that everyone watched network television, but now everyone has lots of different options of how to access content. And you can think about musicians and videographers and artists and kinds of people that now have different ways of getting content to people. So I try to emphasize that it has to be computing, though, because if we think about technology, I think this relates to the next question. There are a lot of technologies that don't have anything to do with computing. So I also try to emphasize that an impactful innovation is one that's where we change the way we do something. So it could be an algorithm, could be a process, but mostly those are ones that can be implemented on a computer, like a sequence of instructions that can be repeated. So that's kind of central to computing, right, is that we can actually devise and automated processes that can do things for us and make sure that there aren't errors. So I think the key factors to discuss are finding ways to see how computing has changed, what goes on in people's everyday lives, even like, how people take orders in a fast food restaurant, or how chain stores like Target, for example, keep their inventory and mark things on the register, and what's on your receipt, for example. These are things that people do every day, and they have to be very different if we didn't have devices, we didn't have computers. I think it's key to connect the things that people see every day.
Cool. Just piggybacking on that, there is always a conversation, Tiffany, about affecting a small population versus a large population. What are your thoughts about that? how valuable would one over the other be in your opinion?
Well, that's a really good point, because the question has impact on society. Of course, that implies that we would like to talk about innovations that have an impact on a large population of people. So that probably be something that would be better for an answer on an essay, for example, for the principal's AP exam, if it were something that impacted a lot of people. But most of the things that the students would encounter every day are that would impact a lot of people, because a lot of people have phones, a lot of people shop, a lot of people go to drive through, a lot of people watch and at the internet. Now there are people that also can't do those things. And that's part of what you might discuss when you about impact, because we really want to understand how these different innovations, these new inventions, are actually changing people's lives. And some people's lives are changed for the better. Some people's lives are changed for the worse. And in fact, many people's lives are changed in both directions. So even if we're talking about something that broadly impacts a lot of people, we also want to think about who are the people that might be negatively impacted and who are the people who have no access. So thinking about who has access to all this would be a way for thinking about how there's a broad impact. So something that maybe even only a few people could access actually could have a broad impact. So for example, maybe there might be some new excuse me, computing innovation that only a large bank could access. However, that's only if, companies an impact on a huge number. So, for example, could see all of the information about all of their customers all of the time, and there might be a single person that would have a lot of power to see what people are doing. Maybe that isn't appropriate.
Sounds excellent. Thank you. Questions from the audience? Any questions? I see a lot of conversation. It's kind of exciting to see so much happening in the audience. Any questions? Before I move, some of the things that are very valid points that Tiffany brought out. Thank you so much. Thoughts before I move on to question? Thank you, Stephen, too. Couple. I'm just going to wait for 10 seconds. Okay, they're introducing themselves, which is kind of very nice. I'll move to the next question. Please feel free to type questions out there. Melissa's out monitoring it. Computing. We use the word computing innovation to understand the impact of innovations on society. Students may confuse this term with other popular buzzwords like technology, computer science, etc. Paul, you're not talking about this, and it's one of my peeves. Technology is such a loosely used word. At the time, I find so many teachers coming in telling me, so does it have to have programming in it? Does it have to have language? So how do we help students really nail down computing innovation that reaches our idea of impact of the computer in society?
I'm sorry, Deepa. I tried to mute myself and I hung up my phone by mistake, and I've been trying to get connected back in. And Melissa, if you're still there, I keep getting an error message, even though I'm connected. It's an error occurred while attempting to dial out. Hello?
Keep going, because we can definitely hear you okay.
So the point is, if you want to answer.
Okay, I'm not going to tell you anything. So I'm really sorry, Deepa. Can you repeat your question?
Totally. So I'm going to read it and then kind of elaborate on what I'm thinking. So we use the word computing innovation to understand the impact in society. Students may use this term, many other popular words like technology, computer science, etc. As teachers, as thought leaders, as higher professors, how do you think students understand the difference in these terms? I added this on, Paul, that you and I had several conversations on this, that it's not pet peeve, that students, use the word technology very loosely here, which ends up confusing students a lot, and really have teachers come very confused. Does the innovation have programming in it? So would you understand this a little better? What would be a valid innovation that we think a student should explore so that it matches the vision of CS principles, idea, impact?
Well, I mean, I think the most important thing is that it's a technology that's had significant impact on the student. And sometimes it might be a little bit hard for them to understand. I mean, I don't know, they say that games and things like those may have had an impact, but I think you really need to help them look a little bit further to see that the technologies that maybe they're using really have changed the way that they do things from day to day.
Right. Go on. I'm sorry.
Well, I was just going to say, this is kind of probably a generational kind of difference. But, for example, I think a good example of a technology that had a significant impact on me, and I think on society as well, is our GPS. I mean, a lot of us think about using GPS car, but I'm very rarely lost in the city. I remember not being a native New Yorker, and there's native New Yorkers in the crowd here, but I would come out of the subway and I'd have no idea it was north, south, east, or west, and I'd have to walk a couple blocks to see which way the streets are going before I really understood which direction I'm in. But now with GPS, I'm very rarely lost. I know exactly where to go. It makes navigating, although that's GPS, but tools Google Maps make navigating using public transportation a lot, I think easier to use. And those are things that I think have had significant impact.
Right. And when you think of GPS, Paul, do you want the students to understand somebody wrote a program there? Do you want them to understand that it's the networking and the satellite and the technology? What exactly do you want them to explore? All of it, some of it, the thought?
I think is they should explore whatever turns them on and get excited. If it's the programming, look at the programming. If it's the way satellites work and understand some of the basic algorithms that are used to determine their location. I'd look at, algorithm like that's the shortest path, so they kind of have an idea how it's finding the path that you should take. There's just so much that you could look at there, and I think that's the real value. We're looking at impact on society to this extent, but I think what's really important, especially in principles, is something that's impactful and exciting students.
Absolutely fabulous answer. That's excellent. And that's it, right? What excites a student, and that's why they want to come to class. Too often I tell my students, they say, listen, social studies, math, not to downplay any value of these courses, but that's a listen and answer question. And when they come into our classroom, we get to do something that's fascinating and open-ended and explore, and hopefully there should no need for them to go to Minecraft or any other game. Thank you so much, Paul. So questions from the audience as I move on to the next question. I see a lot of conversation. I would love for the audience to ask a question of the panelists.
Looks like tutors are suggesting that good ideas are technology that the students in schools like iPads, and is the big talk applied for the Chesapeake Bay. So something developed for a local app contest. And then Melissa mentioned EMAX. And on the chat, we were discussing local versus global impact. So I don't think you have to have the global impact. The local impact is great. The ones that the students can see are that we want to help.
Thank you, Tiffany. That's awesome. Moving to the question. I thought it was absolutely fascinating listening to the talk, and we were discussing, the thought on just the big idea impact, and it was honestly very fascinating to me to see how many of us pilot instructors were so much on the same path of thinking as to this question. One of the CS principles curricula bases the performance stack on impact. Other than creating rich documents, what other ways can we assess how students understand the impact of computing innovation in society? Baker, your wisdom?
Sure. One, it was reported that I'm very soft. I wish that there was anything I could do about that. I'm loudly using my phone. Also, I do a crying baby in the background, so sorry, he's a floor away, but you can. Okay. And he's doing just fine. So this is a good question. What can we do besides research into innovation? This is a good feedback on what Paul was saying about, kids should do something that piques their interest or that they're interested in. And one of the things that we've been thinking about when doing our curriculum is essentially how do you operationalize that behavior in students? It's one thing to say they're interested in the computing innovation, but how do you get them to really see both what is innovative about it, and what the impact is, and to sort of feel that impact. So the way that we address this in our curriculum is, I think, on the big idea of impact, we really focus on trade-offs that you have to make, getting at this sort of issue of the beneficial and harmful effects of computing. There's a lot of questions of that in the performance tests, so we really focus on it in our curriculum, in particular in our unit called data. There's a very strong connection between computing innovations and the data that is used behind those computing innovations that often represent trade-offs people have to make. So in our curriculum, we have a program tool called App Lab, where students, after they've learned a program, begin to write programs that essentially have a back-end database. And as soon as you program that asks the user, it was a program that you can share the user to give you their name or their location, any sort of personally identifiable information, you immediately open the door to begin to ask questions about sort of the beneficial, harmful effects of that. And so our approach in the curriculum is to have students make not just research things, but create things that are similar to what's out there in the world, that maybe it's a small little application, but it has the same mechanics of something like Twitter or Facebook or something like that, so that they've had a little experience that they can understand the choices that a person has to make when doing these things, and that will be able to open their eyes to do the kind of research that they need to do into computing innovation. They might recognize what is innovative about a particular approach, that they might be able to do it a little better, sort of the beneficial, harmful effects are. So in our curriculum, we're very interested in creating, because that's what they have to do for the course. So we try to get learnings about impact. We want those to carry along with what students are creating and the choice that they're making when they're creating them. I'm going to point out that I saw a question float by about sort of community impact or local impact versus global, and I think that that's right. I think that for students, in order to really get engaged with the material or the data, you want to do as much as you can to make that data about them and about their local situation, that data that they have intuitions about, that they can really tell whether it's sort of right or wrong, that they can immediately ask ethical questions about. So it's not that you can't build up to the more global impacts, but if you start with like the big picture, students may not have as much experience thinking about those things. We want all students to create and build things themselves that we can leverage as a common experience to look at more impacts.
That's very, very exciting, Baker. There's some questions from the audience that I thought of that you might want to pick on. Joanne, she kind of is playing devil's advocate. She says, is it really important that students appreciate what we have come to appreciate? Online search rather than hard catalogs that will never be relevant to their lives. How important is that?
I mean, I think that is the question. Like, is important? Do we need to tell students what it was like before we had GPS?
Right.
Or before we had search? And I think that's a really good point. I don't have a good answer. I think that if, as a curriculum writer, I would rather have students build and create things that sort of currently exist in order to appreciate them and their sophistication, and look forward to sort of the next innovation that might be coming. Because I don't know, it might be a hard sell to, other than through a simple prompt, question prompt, to get to appreciate the difference between sort of how it was before the computing innovation and how it is now. There might be other approaches, but that's kind of how we think in our course.
Yeah, let me just toss in, I think what's really important is that we don't get them excited about the things that we have seen that have an impact on our life. For example, Baker mentioned Google and search. I think it's probably the case that all that are taking these courses right now have never known a world without search. I think it's kind of hard in a way to help them understand that. So I think they have to be very careful. And, when I mentioned GPS in my example, to me that's kind of it's a generational example. I remember the days before there was GPS, and I can understand the impact it had. And I think what's important is that we help. One of the things about taking this course, and one of the neat things about dealing with computing technology and technology in general, is there's always going to be these things that are going to have an impact. And I think what's important is to help the students find the things that can see the impact on, rather than listening to me. When I went to school back in the old days, I walked up low ways to school in the snow and blah, 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 blah. It's important to get them to find the things that have had an impact for them, not necessarily for us.
Well, I would disagree a little bit. Just because things aren't visible about like how we did it before, doesn't mean that students do them now. So plenty of times when your technology doesn't work, where you thought you'd get to the mall, meet your friend, but you know, texting wasn't working and GPS was working and you could find your person. So I think there's plenty of times when students are relying on technology that it might not work, and that's where I think that they get plenty of examples from their personal lives where they can say, oh yeah, we were trying to get to this party, GPS wouldn't work, and so we couldn't even get there because we'd already left the house and we didn't have their phone number. All we had was the address, and we had to go to a gas station and buy a map. Or, you know, things happen that, you know, make it so that our technology isn't always serving the purpose that it usually does. So I think people can...
Right, but, you know, I was just going to say we're agreeing, because that's an example of where the student sees the impact. That's what I'm saying. What I don't want to do is convince them that something has had an impact because I've seen it, but they don't see it. But as long as they see that impact and they can feel it, those are the things that I think be encouraging them to look at, to look at.
So I think one way to sort of get at this, or sort of bridge history, and it's related to some comments I'm seeing coming up in the chat, which is one way to look back is to sort of explain, to help explain why things are the way that they are now. And we do that a little bit in our unit, but like a good example of this, like, why binary? Who decided when? Why can't I, is every device that I get, why is the memory always power of 2? And so I think a way to sort of appreciate history or look back is to help explain why things are the way that they are. And that's really important to see a principles course too, because I think one of the biggest mysteries when I deal with high school students, they're afraid to admit to know that much about computers. A lot of the adults in their lives have been telling them how good they are with technology, and the students might not believe it themselves. And so there are a lot of things that we just take for granted, whether it's technology like GPS or the that every device I have has the memory power of 2. Why is that? Like, let's get to the history of that, the reason. And people did say these things. And those historians have an impact on how the way we do things now. And sometimes limit our innovation.
Right. And I want to bring out something that is in the chat window just while we're on the history here. Is something that Rich has cited. Can students think about what innovation will not have long impact forward without seeing the impact of the past that were shot? And that would be a great question, and something that is quite a lot of things to think about, like Facebook. It's had a phenomenal impact on our lives. It's changed and we're never looking back. But there have been things that have not stayed that long. And what is it that makes things really have an impact on society? What does not? Is something to be really considered about. And I had one of these questions here is to talk about what would be good examples. The audience has a rich selection of what possible would be a good ideas for exploring, and we will talk about that. And hopefully, I know Melissa does this. She actually captures this and she sends it to all of us. We really, when we capture the conversation in the chat room, we will have a lovely list of possible innovations that we could use from the classroom. Thank you so much for the conversation that's happening there. Throw this out to the panelists. Baker, if you would start with this one, but I really would like for Paul to also pitch in. What research resources do you use in your classroom for students to explore the impact of computing in creating new innovations and ideas? So, what would be a valid one? What you could say, now, you know what, this is just not something that we would use. Or this is a good one. Would you suggest, would you let them go do what you do? Baker?
So, yeah, I'll try to be brief because in our curriculum, the primary way to use research to look at computing is related to our work and study of the internet and for privacy and security related issues. We have to look at things about digital censorship, about surveillance, and something else, like these big sort of global issues about people's freedom, security, and privacy. We relate it to internet, and that's how sort of get the impact of those things and the trade-offs you have to make, sort of the social trade-offs you have to make considering the security and privacy issues. We don't have a ton of research resources yet about or looking at current computing units. One of the ways that we are doing it, though, is through data. So having to look at what data is publicly available. So our research resources are more about looking at the data that is out there, data that they can collect themselves and sort of compute on themselves. So that's sort of a nuanced answer, but that's what we do.
Tiffany?
I think we use to discuss, I was in a college classroom, so the reasons we would use would be just discussing ideas. I'm also a researcher I do human-computer action and also design of games. And so that means I'm always looking at interfaces of things, and so we talk about those a lot. So we talk about the games that you have. As far as research resources would go, we are also constantly printing students to articles. The Blown to Bits book, has quite a lot of references to particular technologies, and then we might get started with something like Wikipedia, although those are, Wikipedia is kind of a, not a super well-respected resource. Every Wikipedia article at the bottom has references to papers that the students could use, so they can go to those primary sources to find out about things. So we would primarily use Google, Wikipedia to find things, and then go to the original resources that might have been referenced in those things. But I really like the idea. I really like the idea of using data sets also, because those things can really have a big impact on students caring about doing this. So I think I saw one data set that someone was showing me, just an example on the data exercise about how I think whether technology was adopted in low-income neighborhoods in a particular city, and it was the cities are going to school, and they were using mapping technology to see where people lived who had access to different things, and that was a really cool way to research. So I think that intersection of data with technology would be a great thing to explore.
Excellent. And while we have Tiffany still talking, I wanted to say something that Tiffany had put out in the chat window about a book called 7 E's by Neil Stevenson that speculates on a future where people have to get the earth because it's going to burn out. As teachers, we're always looking for someone reading this I thought this would be of value right here. Paul, thoughts before we open up to the audience on questions?
I think Baker definitely covered just about everything that I've done. There's obviously the internet, there's obviously searching, there's, again, I'm in a higher ed setting so that I can, access some of the papers in a library and so forth, a classroom, but probably the one thing I try to leverage the most is the students and have them talk and have them discuss what impact means to them. Again, it sounds like a reoccurring for me, but that's kind of where I go. What I wanted to ask you to do, though, on question 3, there was another part to it that I was kind of hoping that we would get to. And let's see, unfortunately, my numbering is a little different. Here it is. So the other question I was just kind of interested in the previous one is you said down here at the bottom, other than creating research documents, what other ways can we assess how students understand the impact of computing innovations in society? And I just wanted to, I don't think it's a pitch that I wanted in, but I think I wanted to make sure I got across the point that for the CSP course, the development committee really sees the Explore Performance task as something much more than just creating a research paper. It consists of a number of written responses, which I guess you could equate to a research document, but really kind of the heart soul of that Explore is this computation artifact that the students are to create that is supposed to, in a very creative way, explain or describe or to show the impact that that particular innovation has had. And it's one of the things that keeps me awake at night thinking about how we're going to assess that when we actually do the operational reading. It keeps me awake because I'm excited to see what students are going to produce. It also kind of keeps me awake because I'm a little bit worried about how we're going to come up with ways to accurately assess it. But the point I wanted to make is that at least for the CSP course, this Explore Performance task is much, much richer and deeper than just a simple research paper.
Great. Thank you so much, Paul.
Can I add on to that just a second?
Please, absolutely.
Okay, so Carol, I think on the discussion earlier had said, hey, are there some videos about like what life used to be and what it's like now? I'm sure there are many of those, but what I thought when she wrote that, that's a perfect thing that a student could make a video of, creative, to show what life would be like without your phone or your computer or GPS or whatever it is that the student's excited about. And, it would just be really cool to have that be the thing that they create.
And that is exactly the sort of thing that I know the development committee is hoping will come out of these Explore Performance tasks for the CS Principles course.
There is a question from the audience. Susan B. Could the computational artifact be a video or simulation?
Yes.
Okay. So, yeah, there's a response right there in both.
And I also wanted to, tell Tiffany that I'm going to steal her video suggestion for students about ways to make that the Explore PT fun and creative more than a research paper, because it's really easy to get that impression from the width that it's written up. So that's a really good idea, and I think that sort of as a community, we're all trying to figure out. We know that performance tasks are the right way to really assess students' work, but it's new for all of us, especially in AP setting. So I want to encourage people to sort of ideas and things that work that bring that creativity out of students. Because you can't say, people know that you can't say, okay, you're going to now make a really creative video, go. It's constraints and prompts and ways to draw that up. So we're all looking for those things.
Yeah, thank you. There is a comment here from Anita, or I think was very interesting, maybe with some conversation among our panelists. We are studying the design thinking process source for innovation. And when students are collecting observations, they had a great discussion over the idea that Instagram, Facebook, Twitter, YouTube are awesome sources of observations. That seems like a pretty cool approach to, and maybe other ways to assess impact. You would agree? Questions from the audience? Really, we have open mic right now. We have about 15 minutes before we amazingly exciting webinar. But if you'd like to have questions for the panelists, would like to say something, if you would post them. Melissa, do they have can talk? Be able to talk in? Thoughts? Okay, so Melissa says yes. I want to put some other question here that I would ask, and any of the panelists, if you want to talk, you want to mention this, or even respond to, examples of innovations, which of course have been the source of our rich conversation this evening here. I can do as a classroom CSP teacher, students examine something as like the polishing GPS to a smartphone to YouTube, really extraordinarily fancy, not even fancy as a Google eyeglass or a self-driving car, as much as something simple that they use. It's interesting when you give children an option, how simplistic they go to, and how much they're able to get with them. Thoughts, Paul, Tiffany, Baker, and what you think could be good innovation. Audience, if I can get you to ask us questions. Oh, there is one. There's a question from Josh Bailey. Hi, Josh. Okay. While 90+ universities have attested they will give some sort of credit placement policy, can anyone, Paul perhaps, explain what that means? I'm looking for specifics here. Saying that University X will give credit is not as helpful as at University X we will not give credit for engineering majors, but will give quantitative credit for liberal arts and science students. Can you give clarification on this? Paul, I know you don't have access to this, so I can read it again, but that's kind of
okay, no, I can see it.
Okay.
And unfortunately, I don't think this is a very easy question to answer because, at least in my opinion, I think the high school community is ahead of the university, the higher ed community. I think many schools know that CS principals and CS principals courses are coming. I don't think they've grappled with yet exactly what they're going to do with the credit. They kind of fall into two categories. There are some schools that have CS principal courses that count towards major, and I would assume that in those particular schools that students transferring in AP CSP credit, I'm assuming that they would take that for that particular course so that it would count towards major and whatever else that course may specify. There's other schools, and unfortunately or fortunately, RIT is one of them, that we don't have a requirement to do a CSP like for our major, but We do have a CSP Life course in the books that's available to students at the university to take as general ed credit. So what's probably going to happen at RIT in this kind of the group of schools that the CSP credit will probably count towards gen ed credit, but probably won't count towards major credit where we're talking about major computer science. So I think what you're going to see is I think schools are obviously going to fall into one of those two categories. If I were to try to read tea leaves at this point, and this again just totally me kind of speaking off the cuff, I think the vast majority of schools are going to fall into the category where course counts some sort of gen ed credit, not necessarily towards major credit. It may change, but I have a feeling that's probably what we're going to see mostly coming out of the gate on this.
I agree with that. This is Tiffany from NC State, and we have this exact same situation. There is one difference. I think a lot of schools are thinking about adding, they don't have a course like this, they're thinking about adding one, and at NC State, for example, we're thinking about adding a majors course for majors who think, they think but they not have had much experience with computer science principles. So again, it won't be a required course for majors, but we'll likely put one CS principles as a course that you can take before the first class if you feel that you need more introduction.
Thank you, Tiffany. Reg, that I assume answers the question. These are college courses or to CS principles, and the answer is yes. I have a really good question that's a little different from the topic that's being discussed right now, but I think it's very important. Patricia Beach asks, when discussing a computing artifact in the classroom, when you say no to an idea, what would be an idea that a student would bring that you say, no, don't do that? That's really a good question. Anybody? Brittany, Baker, Paul?
I was thinking, lots of technologies that have changed the way we do things that are really old, like pencils and paper. Those aren't computing, so they're not anything that would be nice. And there's lots of technologies we have, so like some aspects of biomedical engineering might have some computation in them, but like if a student were going to use that, they only talked about, for example, artificial eye and how it helped someone see. They didn't talk about what computation might need to go in that. For example, you would need that eye to have some kind of connection to the brain and be able to send the signals to them about what was coming in from the eye. If they talked about those and how they got the signals to integrate with brain signals, and that how they may have used algorithms to translate what was coming in from the sensors to those signals, then that would be an appropriate response. But if all they did was say, artificial eyes are great, they're not identifying it as a computing innovation.
I think that Tiffany is right there. You say no when the student cannot or is at a loss to identify what is computational about that or where the computing is. But there's another aspect of this which I'd actually like to kick it to Paul, which is we're sort of implicitly talking about the Explore performance tag here and which students are supposed to do on that. And I think there's an interesting question about how the teacher can and cannot say no to a student idea when the student is sort of selecting the innovation that they want to look to. It's probably worth talking, Paul, out the rules for how teachers can and can't assist students in those.
Yeah, I don't think I want to say anything in that because I'm not 100% sure where the College Board is falling on that, and so I don't want to say anything that's necessarily going to be wrong. But one thing I will say is that there is an understanding that teachers are exactly that. They are teachers, and they're going to be guiding these students so totally hands off. But, it can't be done where they actually do the work for this. The one thing I was going to throw in is what I usually do if someone comes to me with an innovation that they want to do, I want to make sure that it's not getting in over their head. I'm looking at the performance task on my computer screen here. It says you will be provided 8 hours of class time to develop, complete, and submit both the computational artifact and the written responses. So I want to make sure that they're not going to get something that is going to be just, they're going to get stuck in it and they're not going to be able to do anything really significant. If they pick a very complex sort of technology, what you might try to do is then, steer them towards a particular aspect of it. It's a reasonable chunk they can get done in the amount of time.
Thanks, Bob. Have your hand raised. Will you be able to help? I would hope. I can't hear you at this point, but I'm hoping we'll be able to. I'm not sure that the question from Lee Kipor. I've just sent you a text message, ma'am, if you would take a look. Or do you care if students work outside of class more than 8 hours? How is it to keep track of this? Lee, this is for any one of our panelists. Yes, Baker, Tiffany, Paul, you have a question. And I'm going to have to say, be our last question because it's 27 and I'm sure all of us have to get back to work tomorrow. So it has been an absolutely lively evening. So let's take this. Tiffany, I know you're responding. You want to take it here to everybody?
Yeah, Dan Garcia just did a call for our BJC teachers last week, and he said he just came back from the CS principal meeting, and they had talked about this, about whether teachers should track what students do at home, and there are purposely no guidelines about whether students can or can't work at home on this task, and the teachers are not expected to try it at all. So the CSP people know that some people will work, some people will not, and that's not expected to be something taken into account for the exam.
Well, I think what I wanted to say on that particular topic is I think you're going to see more guidance in this thing. We've been really hard to get the current version, the performance tasks, and the rubrics out. And now that the dust is kind of settling on that, I think they'll probably go back and talk about some of this stuff. We're talking more about professional development, things on those particular lines. I do know originally the idea was that the students would only work on material in class, and it's how they were going to enforce that 8 hours. As Tiffany said, there may be changing a matter of it's say something by the teacher, but I think you're going to see more guidance on that as we get closer and closer to the actual launch date.
Thanks, Paul. Thank you, Tiffany. Alita, I think Paul's response probably takes care of your response too. You should be expecting more information soon, it seems like. At this point, I'd like to hand the floor and the mic back to Melissa. Melissa, thank you for making all this possible. I do want to give a virtual big pat on the back, a big hug to Melissa, because we really would not be able to do something if not for the amount of groundwork and prep she does. She wears many, many hats and is a very valuable person for EIR, and we are very grateful that they've loaned her to us so that we can do something like this. Melissa, it's yours.
Thank you so much, Deepa, and I have to bring it back and say thank you to you as well. Deepa puts in a lot of work behind the scenes and sends out the invitations to folks, and we're particularly grateful that Baker and Paul and Tiffany were able to join us tonight. It's been such a wonderful discussion, and I really appreciate it. I have to say that, you know, I really appreciated the back and forth and the pushback and debate. It shows what excellent professionals you all are to be able to have those sorts of really deep conversations about things. I did just want to invite you. I know some of you may have found us through our Twitter feed, but I wanted to invite you, if you haven't already joined the CS10K community, then we encourage you to do so. We're going to have a follow-up conversation in what we call our CSP open group, and I can make sure you have information about how to access that if you need it. I'm going to put my email address in the window here if you'd like to reach out to me and get some special assistance on that. We do hope you also follow us on Twitter at CS10K. And in addition to these webinars, we've started doing, in the month of October, we did them weekly, but from here on out, we'll be doing monthly Twitter chats that are going to be on the fourth Monday of the month. And this month, this actually happens to fall within what probably will be for many of you your winter break, but we're going to have it anyway, on December the 28th. And it kind of happened appropriately, but we're going to do this one on kind of how do you deal with those mishaps and emergencies that happen. So, for example, you planned this wonderful lesson, and then all of a sudden the internet's down, and you needed to be able to get online to access it. What do you do then? So we encourage you to tweet at us if you do have emergencies or mishaps that you'd like for us to use as kind of posing questions to the groups. So we can certainly include that in our discussion. So again, we hope you'll do that. And I also wanted to share, I should have included this on the screen here, but look out for us in the Twitter feed. To answer your question, Joe, we will be publishing the address of the recording for this. We'll tweet that out. That's probably the